Hi. I want to go over the screencast or make a screencast of the solutions to the vector homework notebook problems. And I know some of those were kind of challenging. Some of the ones involved a lot of trigonometry, probably a couple of the riverboat problems. But my goal is to have you get enough practice where you can get good at them. And when we use vectors all year, you'll be able to be successful at that. I think the key thing is making sure you draw pictures. Draw lots of pictures, a lot of triangles. Make sure you've got your calculator in degree mode. And then you should be able to use the same trig over and over a number of times. So hopefully that'll work. If you have questions, again, please let me know either during office hours or send me a remind message. Thanks. So here's the vector notebook problems. And again, I think a couple of them are probably pretty straightforward. Others may not be. So when I look at number one, it said a submarine was diving at 10 degrees below the horizontal, and you wanted to find the horizontal and vertical components. So you do need to be in degree mode for this with your trigonometry to make sure things go well, and you do want to draw pictures. So to find the horizontal components, I know that the sine of an angle is equal to this opposite side over the hypotenuse, and in this case that opposite side is the vertical side. So I rearrange that, multiply both sides by 110, so 110 times the sine of 10 degrees equals 19.1 meters down. I do the same thing here, but I'm using the adjacent side, and so that would get me a 110 cosine of 10 degrees, and that's 108.3 meters horizontal. Looking at number two, it was 2 golf putts, and to find the resultant. So it said you have 6 meters east and 5.4 meters south. Hopefully you know by now to draw vectors tip to tail. So the first one starts here, points toward the east. The second one starts at the end of the first one in our vector diagram and points south. So when I do that, I get a resultant going to the southeast. It's around 8.1 meters. To find the angle, the tangent of an angle is equal to the opposite side over the adjacent side. So opposite over adjacent is equal to the tangent of that angle. But to get the angle all by itself, I have to take the inverse tangent function, which is using the ratio of these sides to figure out the angle. Again, you definitely want to make sure you know your order of operations and have this correct in your calculator. So that would give me 42 degrees. So the way I've drawn it, the resultant is around 8.07 meters at 42 degrees south of east. If you had drawn this differently, where you had drawn the arrow down before you drew it over to the right, so you did something like this, oops, and then you did something like this, and you'd be finding this angle in here. Using inverse tangent, that would be 48 degrees east of south. So that's the key with that. And I don't know why I have that 42 degree there. I am going to get rid of that. That's weird. And so I think that's what's happening. And so we will go from right there. Custodian just came in, and so she'll be in just a moment. Again, probably. Okay, so now thinking about problem number 3, I've got all these things going on here, and I want to make sure I look at it. This person walking this path. So what I do is I draw this out. I know my resultant should be going to the southwest based on my drawings. So I come up with a unit vector box. One direction is north or south, the other is east or west. I chose north and east because those are both positive in the x direction and positive in the y direction. So I end up with 0 meters to the north, 100 meters to the east. Then this one is 300 meters, but it's pointing south, so mathematically that's the equivalent of negative 300 meters north and 0 meters to the east. For the last 2 vectors, they're going at angles, so I draw another triangle for each of these. So this is the third vector, which is this one. It's 150 meters at 30 degrees south of west. So when I look at this, if I want to get the horizontal side, I need to do cosine of 30 times 150. If I want to get the vertical side, I need to do the sine of 30 times 150. So when I get that mathematically, the key thing is here, I've got to put this as a negative 150 because it's going south. And I've got to put this as a negative 150 because it's going west. So these are both negative numbers. Finally, for number 4, I'm going to the northwest. So that means my direction north will be positive, but my direction east will be negative. So I draw another triangle here, similar to what I had this one, because it's the same triangle. So if this is a 60 degrees angle from the west, then that's 200 meters. Then the horizontal component would be the cosine of 60 degrees multiplied by 200. The vertical component, which is the opposite side of the triangle, is going to be the sine of 60 degrees multiplied by 200. And again, this is negative because I'm not going east, I'm going west. So when I add all these up, I get plus 100, 0, minus 129.9, minus 100. I get minus 129.9. On this one, I get minus 300, minus 75, plus 173.5. I get negative 201.8. So now I'm honestly about 90% of the way done. I'm going to use this north component, which is actually south, and this east component, which is actually west, to draw a new final triangle. I like to draw the longer edge of the triangle first, so it's 201.8 down, 129.9 to the west. You could have drawn it to the west first and then south, wouldn't matter. So the resultant overall using Pythagorean theorem is 240 meters. That's this part. Right there. And the angle, if I use opposite over adjacent, that's equal to the tangent. So inverse tangent of 129.9 over 201.8 gives me 32.8 degrees. So overall, this resultant is 240 meters at 32.8 degrees west of south. Or if you set your triangle up differently, it could be 240 meters at 57.2 degrees south of west. 4 was probably the easiest problem of the bunch. You've got a plane moving to the east and a tailwind going to the east. So since they're going the exact same direction, you just add them up. And relative to the ground, the plane would be going 200 kilometers per hour to the east. 5, you have to actually, it's a little sneaky. So it says that two forces are acting concurrently, which means at the same time. On an object, one is going 28 newtons and the other is 15 newtons at 35 degrees from that angle. So I can't really do this any way other than back to what I did with number 3, which is one of these unit vector tables. So to make my life easier, I'm having one of the vectors on an axis, so there's no trigonometry. So I'm showing this going to the east and this going to the northeast by 35 degrees. Now, do I know it's really going east and to the northeast? I don't, but I'm only asked to get the magnitude here, and this is one way I can do that. So overall, 1 is going 0 to the north, 28 to the east. Then if I look at this one, and notice again I'm redrawing this over here, I've got 15 newtons, the east side and the north side. So to find the north side, it's the the sine, because it's the opposite over hypotenuse. So north over 15 is equal to sine of 35 degrees. So rearranging that, 15 times the sine of 35 degrees equals 8.60. And then going to the east, that would be 15 cosine of 35 degrees. So when I add all those up, I get 8.6 in one direction, 40.29 in another. And I use Pythagorean theorem to get my overall. Actually, that doesn't make sense. Let me check. Let me do the math. Want to make sure I check and do this right for you. It's 41.2 newtons. I have got to change that. So that is a 41.2. I will fix that. So 6 and 7 are vector problems that involve riverboats. I pointed out that you should maybe think about going to lesson 1G in the physics classroom tutorial on vectors, forces, and motion in 2 dimensions, which I can show you here. If we do this. So the physics tutorial is here. Vectors, motion, and forces in 2 dimensions. Lesson 1G. Some riverboat problems. So headwinds, tailwinds, stuff like that. At any rate, so this is a person who, our motorboat is steaming due east at 12 meters per second. So that's my little boat. God, it looks awful. And the river has a downward stream current of 3.5 meters per second. If it is, the boat is heading due east or directly across, I want to find its resultant. So I'm going to draw the boat's velocity and the river's velocity tip to tail. My resultant is going to be going to the southeast. So using Pythagorean theorem and trigonometry, I get that it's going 16.3 degrees. So I'm going to call that downstream, and that it's going 12.5 meters per second. The next thing, as I'm asked, is to figure out how much time it takes to cross the river. Now you might think, since the river was given as 1,360 meters across, I do 1,360 divided by this 12.5. But the problem is the 12.5 is going at an angle, and then both the 1,360 and the boat's velocity relative to the water are going horizontal. So I need to take the 1,360 divided by the 12, not the 1,360 divided by this 12.5. We want to use the like part of this triangle. Horizontal part, which is a distance, horizontal part, which is a speed. If you mathematically could figure out what this would be at the diagonal at this angle downstream, you could use this 12.5 meters per second and that resultant distance, and you get the same answer as we get by using horizontal and horizontal. So at any rate, that gets me 113 seconds to cross. Why? Because distance divided by speed gives me time. And I talk about the reason we use 1360 and 12. So now the last part of it's asking how far downstream was the boat carried. Well, if it's in the water for 113 seconds, and in every 1 second it's being carried downstream 3.5 meters per second, then that's somewhere close to 400 meters that it's carried downstream. The last one here is something that's headed up at an angle. So in this case, it says the swimmer wants to end up directly across from where she starts. So if she wants to end up here, if she starts off here, she's got to aim upstream because the current is carrying her downstream. And in this particular case, then, she can swim 9.5 meters per second, which is ridiculously fast. The current's 3.75 meters per second, also pretty fast. So this one is pretty similar to one of my example problems that I did in my lecture. So to find our heading, we need to use trigonometry. So that's inverse sine of 3.75 over 9.5. So opposite over hypotenuse, and that's 23.2 degrees. So she should aim 23.2 degrees upstream to end up over here. So notice that if I want to find out the resultant speed, I'm drawing my vectors tip to tail, so going up and to the right, and then coming down with the current. And my resultant, as always, starts from the beginning of the first vector and ends at the arrow tip of the last vector. And so it's going due east. And I think that does it.